Hello and welcome back to Intelligent Automation 2020, brought to you by Digit. This is a virtual conference and it's absolutely live. It's startlingly live. Sometimes it would appear sometimes. Anyway, this second session will provide a series of individual case studies intended to provide an insight into the practical application of IA technologies across three different sectors: financial services, Industry 4.0, and environmental monitoring. David, thank you again. And our next speaker is Steve Evans, who's Chief Technical Officer for Global Enterprise UK and Ireland Nokia. And he's going to be speaking about enabling Industry 4.0. So hopefully Steve will be online. Steve.
Hello, and thank you for having me. I'm glad to be able to present to you guys, and hopefully what I have to say will be of some interest. I'm going to talk a little bit about Industry 4.0, a little bit about IoT, and also actually about the communications that go around those things. The first slide I'd like to discuss is actually an economic-based slide, and it brings into sharp relief how important Industry 4.0 actually is. You can see it's very simple. You have in light blue physical industries represented, and in dark blue digital industries represented. And you can see the share of investment dollars for both of those industries, and you can also see the share of gross domestic product for both of those industries, and that shows a very stark picture in that the physical industries are well behind, which is probably nothing new to everybody on this bridge, but well behind in terms of investment for ICT. And Industry 4.0 is coming about because there's an economic imperative to increase productivity and efficiency, but actually there hasn't been the technology to enable that increase in productivity and efficiency. And that's where we are. We're at the very beginning of that, in my opinion. The technology is just becoming widespread, and the right technology, I should say, is becoming widespread. I mean, the key there, this is from McKinsey, you're looking anywhere between $3 and $11 trillion in terms of economic value that can be released by Industry 4.0. So, you know, there's a huge incentive for people to adopt technology in what is a relatively relatively laggard in technology compared to the ICT industries. Okay, I just want to be clear. There's a lot of factories out there that are very advanced in robotics and things we've heard today, but in terms of increasing efficiencies to make those factory floors very flexible, you know, 2 days producing, 1 day to turn around, 2 weeks to produce, 1 day to turn around, and this is the whole factory floor changing. You know, to enable that, you need the kind of communications and monitoring and intelligence that is just in the starting. We're starting to see now. So that's the economic view. The next slide is something I made that was very, very basic. And the idea is, you know, for many, many years, we've had all of the data, and the data is anything from, you know, temperature of a bit, it's the ambient temperature, it's any friction, it's any kind of information that can be used in any process, whether in production of cars or whatever, any kind of process that can be used, and then once understood and learnt, can be used to improve that process, right? So that data's always been there. We've never really had the capabilities to grasp that data, but we've heard, from several speakers, Dr. Suzuki, for example, talked about IoT sensors before. These sensors there's a proliferation of sensors now, which can be used all over the factory workplace. Then we have intelligence on the other side. Now, we've also heard about artificial intelligence and automated intelligence and all of the kind of things that we can create to make use of that data. Where I see the problem is how do you get that data to the intelligence, and in many cases back to the endpoints, to maybe change those endpoints based upon the intelligence. That problem is just about, in my opinion, to change. So with the advent of particularly 5G technology, but also 4G technology, using these radio-based technologies in an environment to enable a data flow to the intelligence in real time, I might add, is in my opinion going to accelerate incredibly the Industry 4.0 proposition to enable the data to be gathered and have something done with that data, something useful done with that data. Okay, so that's where I'm going with these slides. The next slide is a very busy slide, but I wanted to draw your attention to a couple of kind of use cases. So, 4G and 5G are both very, very useful technologies to enable a transfer of the data and also the control of the end component from which the data came. So, changing the torque on a drill bit, for example, could result in less problems or less failures of the particular item that you're constructing. So this kind of monitoring and understanding and turning around that data and putting it back is critical. So some of the things we're seeing is all of these industries are trying to create digital twins such that they have every asset is understood digitally. And more importantly for these companies is the ability to track these assets. I'll go into some examples in a minute, but the ability to track the assets in real time can significantly improve the operational efficiency. I mean, you imagine, the warehouses or ports or anywhere where there's a significant amount of physical traffic. Real-time tracking has an enormous benefit. I mean, even if you relate this to hospitals, just the tracking of wheelchairs and beds and things like that is really important. These things, believe it or not, go missing. So understanding where these things are is really important. If you move to the 5G world, then you start to make use of things that are, mission critical. I want to say that could be life threatening, right? So things that need immediate control. They need real-time robotic control, for example, is really important. And I'm working with Toyota on this at the moment, and it's really important to be able to have absolute guarantee that if should there be a failure, then remote control to immediately halt production or whatever process is ongoing is really important. And these radio technologies allow that to happen. So in the past where we've had physical connections, that's perfectly fine, and there's nothing wrong with physical connections. I personally would take a fiber every time, but it's just not feasible to have a factory or an environment where things are produced that needs the flexibility to change production or to retool. You can't have these physically connected. So I think because of the proliferation of this very low latency technology in 5G, I think we're going to see a huge change in industry over the coming few years. A couple of real world examples. So you might imagine that, the reason I'm talking about 4 and 5G is because it's what puts food on the plate for Nokia employees, and to a degree that's correct. Nokia does a huge range of things wider than mobile technology, but of course it is first and foremost in our minds. But it's worth talking about some of the examples where radio technology has helped the different types of industries. Now, look at ports. I mentioned ports before about being a high, traffic in terms of physical assets. Well, we instigated, Nokia instigated design and installed a whole bunch of radio technology to digitalize the port. So every single item was tracked. Everything had a digital twin. There was camera technology all over the place, drone technology, monitoring technology. A whole raft of capabilities were deployed, and I had no idea this was going to happen. But the primary use case, where the return on investment was less than a year, was actually from insurance companies, because no longer were people stealing things from the crates in the ports, or if they were being caught. I had no idea that the amount of thefts from ports was so high. Apparently it is. And this is one kind of left field example where technology and tracking technology and monitoring technology is helping to improve the port's bottom line. They no longer have to work with insurance companies and pay out sizable sums for expensive items to go walkabout. The other next one is about manufacturing. Now, Nokia uses its own products. So we have a factory in Finland, as you might imagine, where we're based. And that Finland factory is actually the primary factory for the new production of our latest radio technology. So you might imagine that this factory needs to be reconfigured regularly, and it does. So what we have in this factory is all areas are mobile. They can all be moved around the factory floor. We have automated robots all around the factory delivering items. We have robots that mimic the humans, and then they go along on wheels with a nice iPad, and you can talk to a person. It seems a bit dystopian to me, but that's what they do. And this is all controlled via 5G technology. All of the tools, all of the drills, the welding parts are all controlled remotely. And these are all robotic, and these are all 5G controlled. So you can quickly understand that the ability to change that factory floor is actually very simple now. Everything can be moved around in a moment's notice, and we typically have 2-week production lines. And that's because of the ability to see all of the data, do something with that data, but critically have real-time communications via a radio to that data or to that endpoint. The third example is actually to do with social inclusion and social care. There's no doubt about it. Putting connectivity to those who don't have it makes a fundamental difference to that geography. But it only works if everybody's connected. I can give you examples in America, a place called Chattanooga, where in 2016, working with an energy company, we gave gigabit connectivity to every single person in that geography. And it only took a few years, but now we have Amazon and Volkswagen have both built factories in that area now. So getting this connectivity out to people, or connectivity in general, is actually the underpinning bedrock of of enabling society and industry to genuinely better themselves. Another social example is in city centres, for example, or the urban areas for elderly people. Elderly people need gradually increasing care, and we strive to keep people in their homes as long as humanly possible. And to do that, they need protecting or monitoring. And you can monitor it with things like an IoT device, which will sit on the power source around the house, and we'll see if an abnormal source is on for an abnormal amount of time. That enables the carer to go around and check. So it's so rather than having that person come out into a social care home, they can stay in their own environments and enjoy their own home for a longer period. And this kind of work is irrefutable. We've seen this happen, and on average, it's about 5 years. So there are 3 real-world examples where communication or connectivity is helping society in general. But if we take a look at a more of a UK point of view, we heard Dr. Suzuki talk about IoT in the city actually before. And one of the things that jumped out of that presentation, and something I understand quite well, is unfortunately there's thousands and thousands of things that could be connected, and all of these things are owned by different or disparate parts of the city, siloed city, and what we're crying out for is a homogeneous kind of capture-all platform that will manage and monitor, or at least manage all of the devices in a common way, and normalize that management and upwards point to the application intelligence that can do something with it. But it's key that all of this intelligence is joined up. There's no point in having a smart bin on one side of the city run by one operation and smart parking on another. The whole point is to bring everything together. And we're still really, in my opinion, at the start of that. And there's some cities that are better than others, but we're not in a great place at the moment. I've spoken a little bit. I've noticed the time is pushing on, so I'm going to move a bit quicker. Digital divide and social inclusion and social care are kind of all linked. I've spoken a little bit about them already. We're in a situation where, regardless of what the government tries to do, we have broadband poverty in a number of places. We only have to look at statistics where we see 11% of the UK is covered by fibre connectivity. Portugal is over 40%, for example. So, we're in a place that it isn't particularly great for connectivity, and we really need to do something about it. Because, again, without that connectivity, without that underlying communication infrastructure, social mobility, it will be restricted, and certainly Industry 4.0 will be restricted. And that brings me to the Industry 4.0 point. We're seeing a lot of factories across the UK adopting kind of bespoke ideas and bespoke things. And we're seeing the car industry, for example, doing automation with car-to-car communications, car-to-ground communications, those kind of things. But in my opinion, we're not doing something in a homogeneous way, right? We're doing things in bespoke, disparate ways. And we really need to grasp the idea that unless we get some sort of common understanding about how stuff gets from the data to the intelligence, we're going to struggle. And that brings me to the point on that slide, Ofcom. So what's happening in the UK? Well, Ofcom, off-derided, shouldn't be. It's a great institution, in my opinion. Ofcom has done an excellent job of supplying 5G frequency. So all technologies, all cellular technologies use frequency to communicate with each other. They've released some frequency such that any enterprises, so anybody on this call owns a business, can apply for use of some of this frequency. And what does that mean? That means that enterprises can build their own 5G network inside a factory, inside a warehouse, outdoors, rural connectivity, and do it without the auspices or the necessity to engage one of the major MNOs, such as Three, BT, Vodafone and Co. That's a huge groundbreaking move. Huge groundbreaking move, because it now allows industry to go off and do things to enable 4.0 by themselves. They don't need to rely on anybody else. And that's I can't underline enough how enormous that is for the UK. Other countries around the world have kind of done the same thing. There are many countries that haven't. And I think we will see in the UK now, certainly over the next few years, a huge increase in Industry 4.0 off their own back. So Industry 4.0 companies or asset-heavy companies now can move at their own speed without having to wait for anybody else. I think that's a huge benefit. Very finally, where are we going? Where's radio technology going? How are we going to implement all this, and what kind of timescales? We all think 5G is around. It isn't really. All 5G is doing today is making stuff a bit quicker and making mobile companies, giving them more capacity. That's what the first release of 5G is all about. So it isn't really 5G, as much as the marketeers would hate me saying that. Release 16, which was done in June, that is 5G. That is 5G. That is where we all want to understand, ultra reliable, low latency communication. That is what we need for remote control, robotic control. That's the key thing. The low latency utopia is released now. So we will now see, let's say probably the end of this year when vendors start to release this kind of stuff, release 16 compliant radios, that's when we'll see the real benefits of 5G, the way they were always advertised to be. And it will deliver things like I've said, factory automation, machine-to-machine remote control, those kind of things. Cloud gaming, not really part of this presentation or this forum, but cloud gaming needs that real time, and I think that's going to be enormous. Not that we need our kids looking at the screens any more than they already do, but they will. I've noticed about the time, so I'm going to stop there. There are tons of things I could talk about on this. So I want to thank everybody for listening, and happy to field any questions.
Steve, thank you very much for that. Some very interesting stuff in amongst that. There's some questions coming in already. There's still an opportunity to type in a question for Steve just in the next 10, 15 minutes or so. This came in from Kevin Wilson saying, in your opinion, will 5G kill off LoRaWAN and Sigfox, or will they continue in harmony? Is this an in-joke or something?
I have to confess, I do know Kevin, a very good friend of mine. We go back a long way, but it's an excellent question, and one I can see people asking all of the time. So I think so we have a dichotomy at the moment. So to do proper IoT, long-range IoT, when I say that, to low-cost sensors, so sensors actually that's very relevant. Let's just say a landslip sensor, which they could have, Network Rail really could have done with recent weeks, right? Those sensors are very low cost, very rarely communicate, and therefore things like LoRaWAN, which typically have a very, very wide broadcast area and is a lower cost system, that makes sense. And actually, there's no reason why a LoRaWAN gateway can't be backhauled or communicated with using a 5G technology. So it allows you to get even further out. So I don't think LoRaWAN will be killed particularly. I don't think as time goes forwards and the cost of 4G and 5G endpoints, particularly in release 17, when the very low cost IoT 5G specification is written, I think then you'll see a problem with LoRaWAN and Sigfox, because you'll be competing in terms of cost and distance. So from a long term, 5 to 10 years? I think the answer is yes, it will. But I think in the short term, I think we're probably, and short term being 2 to 5 years, we're probably okay. Thank you, Kevin.
Well, I don't know if you know this guy too, Alan Whiteside.
No, I don't.
No, you don't. You're all right, then. Fair enough. Is Industry 4.0 repeating errors from the first industrial revolution by developing cities at the consequence of rural regions where there's relatively more benefit to be gleaned?
That's a really, really good question. I mean, you're asking a very kind of, human question there. What is human nature? How do we work? But I think given that, and actually just with this COVID problem that we're all going through, it's shining a light on the fact that, we don't need to travel into large cities anymore. We can do things. And in fact, the work that we did over in America, enabling connectivity in a rural area, and actually we saw, Volkswagen and Amazon coming to that area because of the connectivity. I think actually it might not work out the same way. I think because of the connectivity, we might see rural regions actually benefiting. Of course, it depends on government intervention and supplying the kind of funds to enable that connectivity to happen, and hopefully they will. But if they do, then I don't think there will be the centralized errors that I think is being referred to there. Where there is a relatively more benefit to be gleaned, well, yeah, exactly. I think rural will benefit from 5G just as much as the urban area.
I'm not sure that was the thrust of Alan's question. By saying more benefit to be gleaned, I think he was talking about to the suppliers. They will always go for more bang for the buck. So if you can do a job and benefit 10,000 people, or do a job and benefit 10, they're going to do the 10,000 every single time. To them, that half will be given more. Yeah,
that's an operator-based question, isn't it? So the people who operate the networks they've got to report to their shareholders. So that's never going to change. How a company runs and how it has to make money isn't going to change. But I think because with 5G and the way Ofcom has used the spectrum to enable enterprises and anybody to use it under their own steam, I think you're now moving away, and the operators are going to have to come and understand this pretty quickly, because people aren't going to go to operators anymore and aren't going to have to rely on them to give them a 5G bubble to operate on a farm, for example. So I think we're moving away from that dichotomy of being under the auspices of an operator that has to report to its shareholders and therefore has to do an urban environment to get as biggest bang for your buck.
Yeah. It's interesting. I spoke to a bunch of people in Perthshire, rural Perthshire, and they were miles from anywhere. And they got really sick, fed up of trying to get decent connectivity. And it was really important for one of them, because I think he works in the animation industry in Hollywood, despite the fact he lives in Perthshire. So they found a massive source of backhaul at Comrie, Cultibragan military camp. I don't know why it was put in there, but it was 15 kilometres away. And because it's a farming community, they all had diggers and things, and they dug 15 kilometres of trench. Yeah. Then they run in, basically fibre optic cable, etc., and they're connected up. They have ferociously fast stuff there. With 5G, you're saying that kind of effort isn't going to be necessary anymore.
But yes and no. And the reason why I'm cagey is because you still have to get the data to the radio that's broadcasting the signal. Mm-hmm. Yeah, so you still have to get power and data to that area. What I'm saying is the ability to connect hundreds of things in real time in that area now becomes reality. And thanks to Ofcom, anybody can do it. But the fundamental problem of getting data and power, I must add, to a particular location to enable the shining or the broadcasts of that frequency still exists.
I love that expression, shining. That's something to do with the Enlightenment at the same time. I get really frustrated sometimes at just the level of connectivity in areas of Scotland.
Yes, what you don't know, Mark, is one of my previous. I can't go into it too much, but I did a lot of work in connecting northern parts of Scotland, the Highlands and Islands. Mm-hmm. A lot of work, and I know very closely what it takes to do it. and it can be done. So yes, it does frustrate me terribly. And it takes basically, it isn't going, if you leave it, I'm sorry, I'm going off piste here, but if you leave it to market forces, it will never happen.
Mm-hmm. Interestingly, I mean, you probably know this, but the Faroe Islands stood it on its head, and they awarded the contract to a provider and said, right, you can do this, but the proviso is you have to do the remote areas first, and then go to where the money is. And it worked.
Yeah, and that's what Deutsche Telekom did in Germany. The government did to Deutsche Telekom for 4G. They had to do rural coverage first.
Mm-hmm. Yeah, it's always a possibility. Listen, I'll check to see that there's no more questions. I think something maybe just popped up there just now. Here we go. Richard Bradley, thank you, Richard, saying perhaps we should be talking about smart communities and connected communities.
Oh, absolutely. I completely agree. 15 minutes isn't as long as I would have liked. So yes, absolutely. Smart communities and connected communities, especially for, you're hearing that at the city level. That's something that's bandied around a lot at the city level. Not that we're actually doing much at the city level, I must confess, we should be doing a lot more. But there's no reason why we can't do smart and connected communities. We do have to be very cognizant of data protection. Right? And that's first and foremost. And you have to be really careful about the benefits and then the privacy. So that's something that we're going to see coming even more than we see today, actually.
Yeah, interesting. Steve, thank you very much for your time. Much obliged. Thanks for answering those questions.
Sure.
Again, we've got one more speaker in this session, and there will be Q&As at the end of that. But then we've got session 3, and I have to point out at this stage, that is also live. That's the breakout sessions. So I'll explain what to do about that later. But everything today is live, which was painfully apparent in the first session, but everything seems to be, touch wood, everything seems to be running smoothly on this one. So we'll see how it goes. Our third speaker is Ed Mitchard, Chief Scientific Officer and co-founder of Space Intelligence. And he's going to be talking about leveraging machine learning and satellite data to help combat climate change. So Ed, over to you.
Great, thank you very much for the introduction. Delighted to be invited to speak to you today. So we're changing tack somewhat, and I'm going to be talking to you about satellite data sets broadly and how we can try and extract rich data from this massive deluge of satellite data that's being collected over the Earth every day. So I'm from Space Intelligence. We are a small startup, started in 2018, based in Edinburgh. And you'll see some of the types of projects we work in during this presentation. So I'm going to start by introducing satellite data broadly, because looking at the delegate list, I don't think many of you have much experience with that. And then we'll move to something where some of you maybe have more expertise and talk about artificial intelligence, and then get on to real world examples of where we do the full processing chain from taking satellite data to making some intelligence or some decision for a company, make that possible. And then, as of the previous speakers, we'll have about 15 minutes for questions afterwards. So there's, as I said, a real deluge of data coming out of satellites at the moment, collected over the Earth. There are several thousand current Earth observation satellites orbiting, almost all in low Earth orbit. So they're about 600 kilometers above the Earth and whizzing around rapidly. So maybe taking 90 minutes or so for orbit, but the Earth moves a bit. So we get revisit times from these satellites from the order of days to every couple of weeks across the surface. These are releasing hundreds of terabytes of data a day, and a difference from maybe the early 2000s is that most of this data by volume is free, which enables companies like ours to exist, really. So this change in model really happens thanks to the Obama administration in 2009, which started releasing American satellite data. It used to be that these satellites were put up there and the data given free to government to do intelligence, and then the massive investment in the satellite systems was attempted to be recouped through private companies paying for data and researchers paying for data in universities as well. However, that didn't really work very well. Not many private companies were willing to pay sufficient money to pay for the investment. And the new model is that the data is given away free. And in theory, this generates economic growth from companies, which then leads to tax receipts and pays for the satellites that way. with additional advantages in terms of this data being able to be used to help fight things like climate change. The European Space Agency and particularly the European Union with its Copernicus program have followed suit and are now releasing masses of free data every day. And to be honest, companies and NGOs and others in various sectors have not kept up with this data, and it's not being used appropriately. So while there are thousands of Earth observation satellites, most of these are actually owned by commercial operators. They're often smaller satellites. And most of these still operate on a model whereby you pay for one high quality image. But some, for example, Planet here, are changing that model more and more to be about daily coverage and purchasing a service. So you might purchase access to data over your area of interest every day or every week. Again, this offers lots of economic opportunities. So there are two major types of satellite data that most of these satellites are collecting. The majority of them are collecting optical data, which can be thought of as a digital camera on the satellite effectively. These collect data in the wavelengths we're used to, our kind of red, green, blue that we see with our eyes. But actually, the atmosphere isn't that transparent in those wavelengths. And so they typically also collect data at longer wavelengths where you get a clearer picture and maybe get some different information. Yes, effectively, these are the passive sensors. They're using the light of the sun to collect data at the Earth's surface. And hopefully you can see this is an image of New York City with Manhattan Island in the middle. And on the left, we have an optical image using red, green, blue. So this is very similar to what you'd see looking out of an aeroplane at a high altitude with binoculars, maybe looking down at New York. On the right-hand slide, I have exactly the same image, but this time it's synthetic aperture radar from the Sentinel-1 satellite, funded by the European Union, managed by the European Space Agency. You'll see this has quite similar features in general. You can see the same rivers, you can see the built-up areas as bright. There's a totally different way this image is collected. This satellite sends pings of microwave data at the surface at an acute angle, maybe about 30 degrees, and listens, if you like, the scatter that comes back. The wavelength here is much longer. This is maybe a 6 centimeter wavelength. And so it's responding to different things. We don't see any color in this wavelength. We're only looking at a single band, but this is responding to objects and how angular and surface they are and the scatters that comes back. So you see some of these big crosses from very good reflectors. And in general, the bigger the skyscrapers, the brighter the returns. So the white areas here are the very built up areas of New York. You'll see instantly that radar is very good for some things that optical data is maybe less good at. So look at the various bridges over the rivers and ocean of New York. Those shine up very brightly because bridges with water underneath are very good reflectors. You can see them in the optical slide if your screen is big, but they're quite faint and small. So there are things that radar maybe does better than optical data, but also it features different artifacts. So companies like ours try and take advantage of different types of satellite data and use the strengths and weaknesses of both. There are some other types of data being collected by satellites. I thought I'd highlight a couple of them. So for example, the GOSI mission from the European Space Agency looked at the very subtle changes in gravity that exist across the Earth's surface. This is kind of an average map you see that shows areas basically where the crust is thicker and where it's thinner. But you can also look in changes in gravity over the year to see, for example, where peatlands are, because broad peatland areas collect a lot of water in the wet season, which means more gravity and lose it in the dry season. So that's a kind of unique way of looking at the world. Also on the right, we see a LiDAR satellite. LiDAR sensors you'll probably have heard of more recently in the context of self-driving cars. These send pulses of laser light and detect the returns, a bit like a radar sensor in that they're active, they're sending their own data. In this case, this is a sensor called JEDI that sits on the International Space Station and measures tree height in individual footprints. This is example data along a transect of about 35 kilometers in South Carolina, and you see the tree height varying as you go along this transect. This is very useful for measuring the carbon storage of forest, which is very well correlated with how tall trees are and not very well correlated with how green they are, which we might use from a different sensor. Because, for example, optical sensors are just seeing the top of the trees, and a tree that's 10 meters tall or 50 meters tall will probably look just the same. So clearly you can use these data to monitor climate change, which was the subject of the talk, without doing any fancy artificial intelligence. For example, I downloaded an image when I was putting these slides together using the Sentinel-2 satellite over California, which you'll know has had major fires outbreaks this week. So on the 20th of August, 2020, I captured this image and you can see exactly where the fires are burning. That's the orange bright spot, active fires, and you see the smoke being blown across the state. So clearly I can tell exactly where these fires are directly from downloading this satellite image. And famously also, particularly radar satellites are used to look at the breakup of ice shelves. So you can clearly see on the image on the right that this ice shelf in Antarctica broke up sometime between the 12th and the 16th of March, 2011. And you see that massive iceberg floating off in the south. So these are quite easy. You can maybe use machine learning to help automate some processes of finding fires or finding ice shelves breaking up. But effectively, there's nothing fancy going on. You can see what's going on with your own eyes. But there are more subtle processes that happen due to human disturbance or to climate change, where data processing analysis is rather more difficult. So for example, something we work on in space intelligence is trying to detect forest degradation. This is where trees are gradually removed from an area, but it essentially remains forest. So if you look on the left-hand side of this slide, you'll see two sets of pictures. So the top row is pictures from the ground. The bottom row is pictures from a satellite. These are of the same areas. You'll see that the two forests, if you go for the left-hand image, the next one along, look very similar in the satellite image. But in fact, they've had about a third of the trees cut down between those two. So there's been quite significant carbon loss, significant biodiversity loss between those two. But it's very tricky to see that from space. As you go further along in term gradation, the changes become more and more visible. But the satellite data I'm using here is the highest resolution data. It's purchased data, it's not free. And maybe using coarser resolution data that is free, you wouldn't see it. There are other classes that can be hard to distinguish. For example, we have done a lot of work on peatlands, and it's tricky to see what's going on in peat because peat is below the surface and satellites mostly see what's going on top. Similarly, a lot of the world is hidden by clouds a lot of the time. We talk about the blue planet for the Earth, but really, if you look at any images of the whole globe from space, it looks like a white planet. About 2/3 of the surface is covered by cloud at any one time. So trying to see through those clouds, again, can be difficult. And often we have inconsistent signals. It's great to have this frequent data where we keep looking at the same place, but it's hard to know sometimes whether changes you see are due to actual changes in the ground or just differences in the sensor or the sun sensor geometry or haze in the atmosphere. In all these cases, I believe artificial intelligence and machine learning can help you find the actual signal and get rid of the noise, just as it does in many other fields. So there's some simpler roles for machine learning and artificial intelligence that are quite well established. They exist, plenty of code, and people like us have been using it for a long time. So for example, often we have a coarser color image, if you like, and a much higher resolution black and white image, where effectively you have a big telescope that accepts a wide range of wavelengths in order to get more light to the sensor. We can use very simple methods to combine those, but using artificial intelligence, you can get better pan-sharpened images, combine the resolution of the panchromatic data and the spectral information of the multispectral. Similarly, identifying clouds can be a bit tricky. You think it'd be a simple thing, just looking for bright pixels. But if you see my images at the bottom here, these clouds often have funny edges and kind of go into wispy bits, so they're quite hard to pick out. We need to be able to mask those out and know where the cloud is so that we can choose pixels that are cloud-free for our classifications, and you don't get erroneous changes. So this is an example where artificial intelligence is being used to build up little polygons that know what clouds look like and correctly remove those. I'm going to give a more complicated example, though, which is more the kind of thing we do uniquely in space intelligence. So, for example, we were approached by Scottish Natural Heritage, who are now known as Nature Scot, which is the Scottish government body that, among its missions, is to protect and quantify Scotland's natural heritage and improve that. They prepare a National Capital Asset Index each year that goes into Scotland's accounts, and their aim, I suppose, is to improve that each year. However, they really struggle to recalculate it because we don't have a good land cover map of Scotland with the right range of classes that show the difference between, for example, degraded peatland and real peatland, or different types of woodland. That's really important. So we won funding from Scottish Enterprise, the Scottish Government, to apply AI to this problem. So we tested this over the Cairngorms National Park using 20-odd classes, which is a very difficult problem to separate some of these classes using satellite data. We managed to do this successfully. Overall, we against a test set of pixels, we achieved an accuracy of 94% over these 20 classes. And we did that by combining lots of different types of satellite data and using machine learning to differentiate these. Ultimately, how we actually did it is not different to many other classic artificial intelligence problems. We use deep learning to do it, and the critical thing in getting an accurate result is using good training data sets, so making sure that all your training data is pure. We spend a lot of time as a team going through, looking at high-resolution satellite data and adjusting polygons to make sure they only include that land cover type. Or, for example, some of our data was based on field visits to sites done by the SNH team, but we needed to make sure that they hadn't changed in the few years, for example, since someone had gone on the ground and the actual end result. So making sure your training data sets is good, and in our case, using many remote sensing layers that are all nicely lined up and processed in the same way. So the difference between, for example, on the right, I have a grid of images that many people spend their time in classes at university, and then companies since trying to develop code that separates out these different little bits of images. They typically have 3 bands to deal with. With our remote sensing data sets, we may have 20 or 30 bands of information. So that involves setting up the neural networks a bit differently, but effectively the way it works is the same. Totally different type of project here is for a company called Max Burgers, which is the leading hamburger chain in Scandinavian countries. It's been carbon neutral for over a decade, which is great. It did that by trying its best to reduce its carbon footprint wherever possible, and then offsetting the rest by buying Plan Vivo carbon credits. In particular, they funded a lot of tree planting in Mozambique in the early 2000s on smallholder farms. But they came to us because Cyclone Idai, you may remember, went through in March 2019 and caused a lot of damage and flooding in Mozambique. I think 10% of Mozambique was underwater at one point. And Max Burgers were interested if this had damaged the trees that they'd planted, because if it had, they feel like their carbon credits might not be as valuable, and they really wanted their consumers to have genuinely offset their emissions from their burgers. So we decided to go and look and see if those trees were actually there. We, with them, purchased our high-resolution Pleiades satellite image from Airbus, which is a 50-centimeter resolution satellite. You can see from the image on the right, the little section of Mozambique and where the satellite was when it effectively just points its big telescope at the area you ask and takes the image. And this is an example of the type of data. So you can clearly see the image on the left shows the whole area, and the purple areas are the farms where the trees were planted. And on the right, you can see a zoom in just to show you an example. You can see individual houses and you can see individual trees. Everything looks good. There are clearly big trees on the farms, so no evidence of massive hurricane damage in this area, which is great. We decided to do it a bit more quantitatively than that. So we developed an algorithm to pick out thousands of trees across this whole image. So effectively, this is an algorithm that's looking for a green splodge with a shadow, because a green splodge without a shadow might just be kind of bushes and things low to the ground. Whereas if you've got a clear shadow, we know that this is a big tree. So we trained this by eye, by drawing around trees, and then developed a machine learning algorithm to pick out these trees. That seemed to work pretty well, and overall we were able to give intelligence back to Max Burgers that we can pick out these trees, and clearly there's plenty of big trees within these farms, so we think that their carbon credits are safe. All right, and that's all I wanted to show you, so I'd be delighted to hear some questions.
There we go, we've got a mic now. Thank you very much for that, Ed. The obvious question from me is, you mentioned Max Burgers there, but who else do you give this information to? I mean, there's a big gap between knowledge and actual action.
Yes, certainly. Happy to answer that in general terms. Unfortunately, many of our clients are doing this for their internal intelligence, so they'd rather we didn't talk about their names publicly. But we have clients including big NGOs that want to understand better what's going on in terms of the lands they manage. So, for example, trying to find illegal deforestation and degradation, or understand where the trees are within their areas. And we have large multinational companies that typically are looking to invest in nature-based solutions. So these are where they might invest in a project that's trying to protect a large area of forest in order to save carbon emissions that might have happened had that been allowed to be deforested, and use that to offset emissions in other parts of their business for corporate social responsibility reasons. So those are our typical clients.
Here's an interesting question from Remote Sensing Solutions in Munich, Flavia de Souza Mendes. Do you know them?
Yes, hi Flavia.
Yeah, right. Okay. Says thank you. This is a real friend fest this morning. Says thank you for the nice presentation. How do you differentiate normal trees from agroforestry systems in Mozambique?
Yeah, it's a very good question. So in this case, in these mashambas, these farms that the Plan Vivo project were working on, typically these farms had no trees at the start of the project. So these were cleared areas where people were growing crops, and the Plan Vivo project helped them plant typically fruit trees or leguminous trees on these farms. So those over 10 years will have grown to be quite big. We couldn't access this area in person. That's why they came to us, because of the related things. So that's why we had to do this with satellite images. But if we see a big tree within a polygon that we know was a farm, we assume that's the trees that were planted by this project.
You mentioned at one stage that you more or less physically had to draw around the trees to train the brain in the first place.
Yeah.
Did that always work smoothly? Or, Michael Bear wants to know good stories about teething problems when training your algorithms?
Yes, I mean, training data is always the killer for all kinds of these machine learning labeling type problems. Drawing around trees is actually fairly trivial when you have really high resolution data. It's easy to see what's going on. But in the case of the Cairngorms case study I showed you, it's much more difficult to really know what you're looking at. Even if you're looking at very high resolution data, it's hard to know whether it's broadly for a coniferous forest, for example, or different types of mires and bogs and grasslands. We found it really hard to separate. So we were very reliant on real ground data collected by the NatureScot team and other people. But often that data is really out of date. It might have been a field survey in the 80s, and we don't know how reliable that is. And it wasn't really collected for this purpose. So often people are giving a mixture of the type of habitats that are found within a few hundred meters of where they are and having a GPS point, whereas really what we need is an exact boundary of where a particular patch of habitat is. So we're hoping to work further with NatureScot and others to improve the quality of the ground data, which we think will then feed through to improve the maps. Obviously, that's been difficult in a COVID environment, but hopefully we can get back out to the field soon.
Just out of curiosity, is there any value at all in feeding in data that dates back to the 80s?
There can be. I mean, ecosystems in the highlands don't change very fast. So, for example, if it's scree in 1986, I doubt it's changed very much at the top of Ben McDewey and the Cairngorms. So I would trust that. But yes, you have to go through these polygons one by one, look at recent satellite data, see if it's likely to have changed, and have some knowledge about how the ecosystems work. So yes, it very much depends
on the individual circumstances. Julian Glendinning from BT says, very interesting presentation and clearly suggests AI for good. Do you ever have to explain or justify the benefits of AI to major stakeholders in the context that some people seem to have an irrational fear of it?
Yeah, it's something we also work with a government-funded AI for good type project by Nesta, which is a UK-wide government organization to do with trying to get people using AI more. And I know they have various education programs about trying to avoid this fear. I haven't come across it personally, I think in this context, because we're applying the AI to satellite data sets to do with land cover rather than people's data or something. I haven't really come across it, but you definitely hear about it. Certainly something I have seen is that people instantly think it's this scary, difficult technology that they can't relate to. And actually running artificial intelligence on satellite data in a simple way, as I said, some of these things that we do are quite simple and established techniques to apply. So some of the things are more complicated, but some are quite established and well used in the remote sensing community.
I think you've partially answered this next one too. John Caldwell says, can you use aerial photography, for example, to augment or identify peatlands?
So yes, you can. Aerial photography is a higher resolution still, so it can be really helpful. We're very lucky in the UK that Ordnance Survey make an effort to photograph the whole country every few years. They often don't get to the Highlands of Scotland as frequently as we might like, but in general, we have good aerial photography available to us in the UK through the Ordnance Survey. And it can be very useful. So for example, with peatlands, you might be able to clearly see areas that have humps and hollows, or maybe that have drainage ditches in the case of degraded peatlands. You really need to know what you're looking at. I think there's a real importance in interpreting aerial imagery to have been to the site and have an understanding, because you can identify trees anywhere in the world. They're very obvious what they are. But in terms of peatlands or whatever, you can't really see the thing you're wanting to look at. Instead, you're looking at the vegetation or the structure on top and trying to get some information or some inference from that. So I think there's a real importance of boots on the ground with these difficult land cover problems.
How close would you need to be to the ground, rather than taking it from a satellite? How close would you need to be to the ground to actually identify individual plant species? Because that would tell you the sort of underlying structure of the peat. It
would. The only way I've ever seen a botanist identify a plant species is by looking at it right next to it. I think you'd have to be really close to get. Botany photographs, you send them, I've done this in tropical forest, you send someone a photograph of a leaf and a fruit and they'll ask you to then go back and tell you if it's hairy underneath or look at it with a hand lens. It's not like a photograph necessarily will give you the information that they would have from actually seeing the plant. But certainly data from a drone, you could imagine getting images that have a resolution in the millimeters. They're more like someone holding and taking a photo above it. And that would presumably be very helpful for a botanist trying to identify a vegetation type. The other information you can get from drones or sometimes from aerial photographs, you can produce very accurate digital surface models, and those can also be useful in differentiating land cover types. So as I said, peat bogs, healthy peat bogs have humps and hollows, so kind of go up and down by ½ a meter. And you might be able to see those structures through UAV data analyzed through structure for motion, so where you take lots of images from slightly different places and stitch the angles together to make a digital surface model.
I was about to say that there are very few governments around the world who don't claim to be worried about climate change and doing things about it. Is that your experience as a company? People are beating a path to your door saying, we need this information, we need it yesterday.
Yes and no. Definitely, I think there's been much more interest in a real way from companies over the last few years. We've really noticed that. So large consumer companies maybe were doing some things for CSR. Some companies, I think, really cared about trying to remove deforestation from their supply chain. And there's been a real movement in the last year or two for big companies to be, okay, we genuinely need to do that. Government is going to legislate to force us to do it. And our consumers are going to stop buying our products if we don't. So I think there has been a switch in terms of multinational companies trying to particularly remove deforestation from their supply chains. We're keen to help them with that. In terms of governments, I think governments have been taking this seriously for a while. I think most governments want to do something to protect their citizens from climate change, but governments move slowly and in kind of fits and starts, and they're big amorphous organizations. So we've been talking to various bits of government in Scotland and the UK about trying to help out in terms of restoring ecosystems or protecting from peat degradation in the UK. But I don't know how fast that will move. But the fact that government is paying for things like this AI for Good program that funded us to look at the Cairngorm suggests they're putting money in the right place to try and make this technology happen.
Yeah. Ed, thank you very much for your time. Thank you for answering those questions. Much obliged. Just to say that the next session, session 3, starts at 12:20. We're going to have a short break before then. As I said to you before, it is absolutely live. There are 2 breakout sessions. You can select one session to attend, and then after breakouts, we're going to have lunch from 12:50 to 13:35. Sadly, no mushroom volleyballs unless you brought your own. We'll just see how we go with that. And obviously take the chance to chat to fellow attendees and the exhibitors at the same time. I hope you've enjoyed the first 2 sessions. You found it useful. Thank you for sticking through the first session. And we'll see you later on with this breakout session in about 20 minutes' time. Thank you.